Hi children, welcome back. So, you are all used to kitchen knives, right? So, we all use kitchen knives to cut our vegetables, fruits, cakes. So, we have already seen and we are well equipped with knives. So, have you observed that there are two edges for a knife? So, there is one sharp edge and there is one blunt edge, right? So, sharp edge is nothing but the cutting edge. We call it as cutting edge because we use that portion to cut. So, now suppose you want to cut vegetables, which one do you prefer? Yes, you will prefer the sharpened edge or the cutting edge. Now, why is that? Why can't you use the blunt edge? So, for cutting fruits and vegetables, we use the sharp edge. And what is the reason behind that? Let me give you another example. So, here, we all are carrying some bags to school, right? So, when you look at a school bag, a student's bag, you can see that the straps are a bit broader, right? So, here in the picture also you can see that the straps are bigger. So, compare it with your mother's handbag or your sister's sling bag or your teacher's bag. You can see that their bags are having a very thin strap like this. But look at this kind of school bags. So, the shoulder bags. Why are the straps broader? Broader than what your mother is having a handbag or sling bag. Now, why is that? Can you think of any reason? Okay, today we will see why is this happening. Now, here, suppose I want to hang a photo frame. I got a photo frame as a gift, so I have placed a picture in that and I want to place it over a wall. Now, I want to fix a nail on the wall so that I can hang the picture. Now, so then I can take the nail, so I can use its head and I can use this hammer to place it above the nail, above the wall. Now, suppose I can even reverse the side of the nail, right? So, I can use the pointed side and I can use a hammer to this side. Okay, let's do that. So, I will be using this side, one case, and the second case I will be using the sharpened edge. So, that is the place where I am going to hammer it. Now, in which case you could successfully insert the nail. So, in which case the nail will be fixed on the wall or the nail will pierce through the wall. Yes. So, if that is always the first case, we always do this, right? So, we will be placing the head of the iron nail just like this. So, this will be the way we will be using this. In this way only, the nail will be fixed on the wall, right? Now, what is the difference? Why? So, look at these figures and what can you see from these figures? Now, let us look at this nail. So, it has, this is the head part and this is the sharpened edge, right? Now, carefully look at the area where the nail and the wall meet. So, here this is the area and here this is the area. So, here the head part is meeting the wall and here you can see that the pointed, the sharpened edge is being in contact with the wall. Now, do you think the area over the force applied, now that is the pointed edge and the end of the wall, pointed end of the wall, plays a role in piercing the wall? Now, do you think is that the reason why this case was successful? Why in this case the nail went inside perfectly, but in this case it was not happening? Do you think this is the reason? Now, the force which is acting on a unit area is called pressure. So, what is pressure? The force which is acting on a unit area is called pressure. So, pressure is nothing but we can write it as force divided by area. Now, let's look at the units of pressure. So, here the unit of force is Newton. So, force, the area of force is Newton. So, I will just write Newton there. So, Newton is represented by N. Now, what about the unit of area? So, let us take the standard, so meter square. So, the unit of area is meter square. Now, can you tell me what will be the unit of pressure? Look at here, look carefully, so you can see that pressure is nothing but force by area. So, can you tell me what will be the unit of pressure? Yes, it will be Newton divided by meter square. You can say that Newton per meter square. So, Newton per meter square. So, that is Newton per meter square. So, we will write it as N, then there is a slash which denotes the division, and then there is meter square. Now, we can even call this unit as Pascal. So, we denote it as PA in remembrance of a French scientist, Blaise Pascal. Okay. So, pressure is nothing but the force acting on a unit area. Now, this is Blaise Pascal. In remembrance of him, we use the unit of pressure as Pascal. Okay, now, so we have an activity here. So, quickly take a sheet of paper and let's calculate the values. So, here you can see that in all these sums, you can see that the numerator is the same. The numerator is nothing but 3. Now, what about the denominators? The denominators are increasing. So, here it is 2, here it is 3, here it is 4, 5. So, it is going on. Now, tell me the values of 3 by 2. Calculate 3 by 2. What is 3 by 2? Yes, it is 1.5. Now, what about 3 by 3? 1? Yes, it is 1. Now, what about 3 by 4? 3 by 4? So, if you say 3 by 4th of something, that is, so there are total 4 parts and there is 3 parts. You are taking 3 parts. So, 3 by 4? You can say that 75%, right? So, it is 0.75. Now, what about 3 by 5? So, 3 by 5? Yes, calculate. Yes, it is 0.6. What about 3 by 6? So, 3 by 6 is nothing but 1 by 2. So, it is 0.5. Now, 3 by 7. So, this, just do the division and quickly tell me what will be 3 by 7. So, you have to find, okay, let us find 3 up to 3 decimal points. Okay. So, that will be, so, yes. Now, okay, so we got 3. So, it is 428. Now, what is 3 by 8? Quickly tell me what is 3 by 8. Calculate. It is very simple. And what is 3 by 9? 3 by 9 is nothing but 1 by 3. So, 1 by 3 is 0.333. So, 3 by 8 is 0.375. Now, look at these values. So, you can see that the values here, so the first value is 1.5, second is 1.75. So, the values are decreasing. So, here 0.5, 0.428, 0.375, 0.33. So, the values are decreasing. Now, what is the change in the fractions? The numerator is the same, but the denominator changes. Now, you can see that the denominator is, in the first case is 2, second case is 3, third case is 4. So, the denominator is increasing. So, denominator is increasing. When the denominator is increasing, then the value of the fraction is decreasing. Yes? So, now what happens when the denominator is increasing? What happens to the value of the fraction? So, the value of fraction will decrease. So, when the denominator is increasing, the value of the fraction is decreasing. Now, let us look at the formula for finding pressure. So, pressure is nothing but force our area, our unit area. So, here you can see this is also fraction. Now, what happens when area is increasing? So, area is in the denominator. When area is increasing, what happens to pressure? So, when area is larger, pressure is decreasing. Now, let us go back to the case where we are hammering a nail. So, there the area of the pointed end of the nail, so you can see that the pointed end is having smaller area than that of his head. Now, when you apply the force, so in the first case where you applied, where you place the sharper edge was in contact with the wall. So, in that case the area of contact was less. So, the pressure will be larger, and for the smaller force you apply, the pressure of that force will be larger, resulting that the nail is going inside the wall. Now, the same force therefore produces a pressure sufficient to push the pointed end of the nail into the wall. Now, when you did it in the ulta, that is when you did it in reverse, what happened? What happened was that the area in contact becomes larger. So, what will happen? So, the nail won't go in. So, you need to apply more pressure, more force in order to do that. Even if you apply more force, it won't push, right? Practically. Now, why school bags are provided with broad straps and not thin straps? Can you answer now? I mean, even for cutting fruits and vegetables, we use the sharp edges. I believe you can say that reason, yes. Now, let's do a simple problem. So, let's find what will be the pressure exerted when 10 Newton of force is applied on an iron block of 0.2 meter square area. Okay, let's write down what are the given information here. So, here we have force is given to be 10 Newton. So, be careful, we have to write units whenever we have something like this. So, force has a unit. So, force is 10 Newton. Now, what about, so force is applied on an iron block. Okay, so there is a block, it is made of iron, and the relevant information what we need is the area. So, area is given to be 0.2 meter square. This is given. So, I will just write. So, given. Now, what is the thing we need to find? We need to find the pressure exerted. Okay. So, we don't know what is pressure. So, we will write pressure is unknown. So, let us put a question mark. Okay. We know that pressure is equal to force by area. Now, so let us substitute both the values. Force is nothing but 10 Newton divided by area. Area is 0.02 meter square. Yes. So, what will that be? 10 divided by 0.2. So, we can write it as 10 by 0.2 is nothing but 2 by 10, right? So, 2 by 10. So, Newton per meter square. I will just write Newton per meter square, right? Now, that is nothing but 10 into 10 by 2. So, if you have a division here, you can just put it in the top. So, this is 100. 10 into head is 100. 100 by 2, that is 50 Newton per meter square. So, that is the pressure exerted when 10 Newton of force is applied on an iron block of 0.2 meter square area. So, we just got it. Now, so quickly take a screenshot of this one. So here I have given some values. Okay. So the first one is what we just did. So we got the answer as 50 Newton per meter square, or we can even write it as 50 Pascal. So Pascal is also the unit of pressure. It is the same as Newton per meter square. So we can write either of this. Now, so I have given four more cases, and in the first two cases you can see that the force is the same, but look at the area. So in this case, area is increasing. Now tell me the value of pressure here. Now in the second, so this is the first, okay, second, third, fourth and fifth. Okay, let's take the first case as our standard case. Okay, we will just look at this case as our reference. Okay, so this case. Now, so this is the first case. Now in the second case we are increasing the area. In the third case you can see that, so compare it with the first one, always compare it with the first one. Okay, so in the third case we have the same force, but the area is decreased. Now what happens to the pressure? Calculate and find out. So pressure is nothing but force divided by area. So F, force is denoted force by F and area by A. So we will be getting this. Now in the fourth case, now look at the force. Force is changing. Now area is constant, area is the same. So here force is 20 Newton. So 20 Newton, so the force is increasing. Now look at what happens to pressure. Now in this fifth case, you have the force is decreased. Now look at the area is the same. Look at what happens. So when we meet tomorrow, find out all the answers for this one. Now what happens when the area is decreased? What happens when the area is increased? What happens when the force is increased and the area is kept constant? And what happens when the force is decreased and area is the same? Now let's find out more about this. Okay. Thank you children. See you in the class. Bye bye.